So one of the keys to parabola is that it is symmetrical. And that's a really important point in physical property of parabolas. So here we have a point. We're given the vertex form, and we want to find a point that's symmetrical to the one that was given. So we already have, since it's in the vertex form, we already have some information about the symmetry. So in this case here, if I were to sketch this graph, it's got a vertex at 2, 3. And it opens up and it's kind of skinny graph. So there's my axis symmetry at x equals 2. So the middle is very important. So at 5 over and 30, we have a point here. And we're being asked to find some symmetrical point over here. Okay, so this is going to be, we'll call that x and 30. So we're basically trying to find x. Again, since we have the symmetry, we should use that property. So we know this is 3 over, so we can just count back 3 and it's going to be at -1. We could also use the property of middle and find the average. Okay, so we know that if we average out the two x coordinates, we're going to get the middle x coordinate, which is 2. So we end up with x equals 2 times 2 is 4 minus 5, and we get the -1 that we can kind of see from the graph. So when we can look at things, that's why it's always good to sketch graphs, because it's always important to be able to see things, okay, and be able to see the math that we're using. So here again, we're given the vertex form. We want to find the vertex, axis symmetry, y-intercept, and direction of opening, vertical expansion, compression factor. So vertex is going to be generated from, and it has to be the vertex form. So if we don't have the vertex form, we have to find the vertex in a different way. So the vertex is going to be at 5, 5. That's the coordinate of the vertex. Okay. The compression expansion factor is always determined by A, and whatever form you're using, the compression expansion is going to be the same. So the A value in the graphing form is the same as the A value in the general form and the A value in the factored form. So expansion by 3 times, and it's a vertical expansion. Okay, it's a positive A coefficient, so it opens up. The y-intercept, now because this is in the graphing form, we cannot say that the y-intercept is that last number. We have to plug in 0. So when we plug in 0, we're going to get 25 times 3 plus 8 plus 5. So y-intercept works out to be y equals 80. And then the roots, we have to find the roots by putting this into factored form. So I'm going to put it into factored form. So I need to expand this. Okay. Or actually, we can do something slightly different. Instead of putting it into factored form, we can just solve for y equals 0. So we're going to let y equal to 0. And that's where the roots are going to be located, where y is equal to 0. So then I solve this by get rid of the plus by minus. Get rid of the times 3 by divide. You want to get rid of that squared by square rooting. Now, at this point here, we can see that we're going to square root the negative value. So at this point, we can say that, well, it's impossible to square root this. In fact, we know that the vertex is 5 up from the x-axis, and it's opening up. Well, I'm just going to highlight this here. This is what we would call non-real. Okay? And the reason is because the graph, if we were to sketch it, it goes like this. Oops. It looks like this, and it does not cross the x-axis. So it has no real roots. Okay? Because we end up, and it's actually connected to this fact that we're square rooting this negative value, and we cannot square root negative.